All right, this is our second example. This time we're going to calculate the percent dissociation. So first of all, dissociation means to break apart. So we're trying to see what percentage of these molecules for acetic acid are actually breaking apart into hydrogen ions and then acetate. This is a weak acid, so we don't know what percentage is breaking apart. It's a low percentage probably, but for strong acids you can assume 100%, but for weak acids you have to actually figure it out. So the first thing you always want to do is list what you have. So we have this weak acid, acetic acid, and we always have water, and that's it. Of these two, the acetic acid has a much bigger Ka. Remember, water's Ka is 1 times 10 to the negative 14th, so negative 5 is going to give you a bigger Ka. So we know that acetic acid is going to dominate over the water. So let's go ahead and set up the reaction. We have an initial amount of acetic acid. We have a negligible amount of hydrogen from the water, so we'll just put a little tilde, it's about 0. And we have 0 of the acetate ion. We're going to shift towards the zeros, and we don't have any coefficients. And we're ready to set up Ka. Which will be products over reactants. We are going to assume that X is very small based on that Ka value. And now we can solve for X. And the assumption is good if you type in X over the original concentration. So you can put that over the original and then times 100. It gives you a very small percentage. So assumption is good. And we can go ahead and assume that X equals 4.2 times 10 to the negative 3rd, which is the concentration of H+. So the last thing is just to do that percent dissociation. So the percent dissociation is the percent of the ions, is how many ions you have, over the original concentration. So you're looking at the concentration of H+ compared to the concentration of the acid that you started with. So this is kind of what we're doing. And times 100. And that gives us 0.42%.